Okay, now that we have talked about hydrocarbons, I'm going to draw you a hydrocarbon here and show you what it looks like. Just four carbons here. This is going to be a carbon skeleton. But carbon is going to be bonded to four things. So we assume that if this is a hydrocarbon, all of these lines are going to be bonds, okay? And these hydrocarbons are made of carbon and hydrogen. So these are going to be hydrogen atoms, okay? And because there's a lot of hydrogen atoms here and carbon, this is going to be a pretty hydrophobic nonpolar molecule, okay? So what I'm trying to show you now here is obviously not all our not of all our molecules are going to be hydrocarbons. Sometimes we're going to add something called a functional group. Okay, and these are going to be our functional groups. So what do functional groups do? There's going to be unique properties of organic compounds that depend on, like I said, size and the shape of the carbon skeleton, just like I showed you here. This is a linear molecule, right? Carbon skeleton. Uh, but also, it's going to have unique properties, mostly because of the group of atoms attached to that carbon skeleton, to that carbon skeleton. And this group of atoms are going to be called functional groups. Okay, which are going to add a special property or add special or unique properties to the carbon-based molecule. They're going to allow for new molecular properties to merge. Okay, so functional groups are going to be attached to carbon backbones, and the most important ones that we'll talk about a lot are going to be the hydroxyl group. Hydroxyl group is composed of an OH. There's an oxygen here, and we know that oxygen is electronegative. So what you expect to see is if you add something like this into a carbon skeleton, now the carbon skeleton is going to have a little bit of a different property because of the oxygen, is going to be actually is electronegative. So you're going to have a little bit of a charge here, right? A positive and partial. So now this carbon skeleton is no longer fully nonpolar. So let's add it over here. Let me do this when I erase this one here. And instead of having an H, I'm going to take it out and I'm going to put a hydroxyl group. And guess what? Now you have a completely different compound. All right. And the thing is, now that we have this functional group here, now there's this functional group is giving this big molecule special properties. Okay. Other type of functional groups that we'll see a lot: carbonyl group. Carbonyl groups are carbon bonded to an oxygen, double bonded to an oxygen. Carboxyl groups, which you'll see a lot in proteins. It's all of this. It's the carbon double bonded to to an oxygen here, and another here, no OH over here. An amino group, whenever you hear amino, think of nitrogen. So there's a nitrogen atom there. And here it is, right? This is an amino group. The whole thing is an amino group. And then sulfur this has a sulfur group, right? And you get to see this in proteins as well. And just to wrap this up, this small little theme of functional groups, here are two hormones. These are going to be hormones. All right, we have estradiol for females, testosterone for males. And what I want you to see is, are these hormones very different? The answer is not really, right? And what you see here, what makes them different, okay, is probably going to have to be something with the functional groups. All right. So I'm going to say difference due to functional groups. Even though they may look very similar, they have extremely different properties. And the thing is this, if we go to estradiol here for women, we see that there's an OH here, okay? And then we see also that this ring over here has three double bonds, right? Makes it a little different from testosterone. Now we go to the top, three double bonds, right? Makes it a little different from testosterone. Now we go to the testosterone over here. This is a functional group over here. It's different from estradiol. This functional group is different from estradiol. And the thing is that here is only one double bond. But that's the only change. Everything is pretty much the same. Now, one more thing before I move on is I told you that carbon can do the skeletons, carbon skeletons can do a lot of different shapes. Well, we see carbon skeletons here as rings. Okay, these rings made of carbon. And whenever you see these rings, what you're gonna see is in every edge over here, if there's nothing else, you assume there is a carbon. Okay, so if there's an edge over here, it is going to be a carbon. It is going to be implied. Okay, unless if you see something coming out of here, then obviously this is not a carbon, right? But everything else, every edge here, every edge of the rings are going to be carbons.